Hello everybody, welcome to section 3. We're going to cover extrusive hazards. So first, where for the most part are we going to be looking for volcanic activity, especially really bad volcanic activity where there's a lot of people? Well, mainly we're going to be looking here at what we call the ring of fire. Probably you guys have heard this before at some point in a general science class. This is a huge, not continuous, but almost continuous convergent margin here at the edges of the Pacific Plate. So we have the Pacific Plate here underneath the Pacific Ocean, and pretty much wherever it is meeting these continents, it subducts. And it is at these subduction zones so that we get not only earthquakes, but also a considerable amount of volcanic activity all throughout here. What are volcanoes? These are the vents where we have liquid rock, debris, ash, glass, dust, gases, all these things which erupt from the interior of the Earth onto the surface. These don't necessarily have to be explosive types. They can be non-explosive. One that we're seeing here is maybe moderately explosive, not the gentlest that maybe you've ever seen, but also not tremendously explosive, not a super violent eruption. We will cover, though, for the most part, do you remember the difference between lava and magma? Which one is this stuff here? Is it the same as this stuff over here? So lava is molten rock that reaches the Earth's surface, like what we're looking at here. Magma is when it is below the Earth's surface, so we would not be able to see it in this photo. We're going to talk about two different types of lava. First, we call Not a joke. This is a Pacific Islander name for it. Unsurprising, remember the Ring of Fire diagram there, that Pacific Islands have a lot of different names for different sorts of eruptions. We will cover two types of lava. These are the type. You might want to remember this because, well, after these solidify, after they cool, they tend to be very rough and jagged, and if you stepped on it, think of what sound you would say. These tend to be slow-moving and highly viscous, and what do you think? Cooler or hotter than other lavas? What do you think? Oh, it doesn't have the temperature on there. So these tend to be cooler than other lavas. They tend to be pretty slow-moving as a result of their being highly viscous as well. And we have actually some slides here. I believe these are all from Kilauea in Hawaii of a eruption, or something that would cool to form lava. Not smooth, very jagged stuff. Some absolutely spectacular photos here. I sincerely hope that these people have volcano insurance, or at least life insurance or something. Probably they had good notice that this was going to happen and were fully prepared for it. Uh, there's another type we could talk about, the hoi hoi. There's a pronunciation on this one. Kind of a smoother word for a smoother lava. A little bit of a forbidden snack here. Smooth, ropey surface, low viscosity. These tend to flow rather quickly. Remember the others were less than 1 mile an hour. This one moves closer to 6 miles an hour, so a pretty decent jog. And these do tend to be hotter than the others, the lavas. Some other hazards associated with volcanoes are volcanic glass, so given off by both the active ones, which might be erupting, and dormant volcanoes, which might have a leak somehow, a crack, a little conduit connecting to the surface. Principal gases we're talking about here: water, carbon dioxide. You also have sulfur, either in oxide form or as hydrogen sulfide. These tend to be pretty deadly. Something like a lava you would expect to be the worst part of it. Generally, it's not. Generally, as far as the destruction of human life goes, you would rather be dealing with lava than be dealing with something like this, which spreads out. There's no running it. Something which comes in 3 dimensions and might be completely silent. You might have no idea that a volcano is emitting these sorts of gases, whereas with an eruption, it's very clear that this is happening. These absolutely can be poisonous, these here, and even though they are hazardous to human life, these are only the second greatest threat to human life during an eruption. And if you want, you could take a moment here, try to think about what would be worse than lava and the gas. What would be worse than those two? What's going to be the number one threat? So we have a couple of photos here of this is volcanic gas leaking out. A couple, something which would be very, very obvious here, something which might be a little less apparent here, and finally we have a fellow or someone here, looks like measuring these. Somebody who I'm sure is very, very confident that their theories and ideas about what is going on here are correct because they're willing to risk their lives. Just as far as certainty goes, is this valuable? Number one thread is going to be pyroclastic flows. So what are we talking about? Talking about this here. Specifically, we're not so much worried about the big cloud, we're worried about all the stuff from the big cloud which comes out and then rolls down the hill. Right? Pyroclasts, we're talking about little bitty glass shards, razor sharp little things, which are suspended in gas and dust and rolled down the hill here. These are hot enough to completely bake and annihilate anything that might be in their way. And these are the greatest threat to human life during interruption, pyroclastic flow. These are not super common. You might remember the photos we're looking at of Kilauea. There were no pyroclastic flows there, or there would have been a much greater threat to human life, and there would not be buildings there if there were pyroclastic flows coming out of those volcanoes. So this is another photo, kind of a spectacular one of a pyroclastic flow. Specifically, again, we're not looking at the entire cloud. Really, we're looking at this part of it, which is rolling and moving downhill, and which contains not only gases, which are going to rise up like this and mushroom, but also all sorts of little poisonous gas, glass shards, little poisonous razor blades, you can think of them as, which are inevitably going to tear everything up that is in its way. This very famous eruption, which saw at the end of Pompeii, Mount Vesuvius, in 79, this was a pyroclastic flow. It is interesting. So what we're seeing here, this is not exactly the original material of the body. Whenever this site was being excavated, what they were finding really were these cavities of a very unusual shape. And as they discovered more and more cavities and tried to figure out what they were, they came to the conclusion that the little cavities that were in the field that they were excavating, these were actually places where human bodies had been covered by pyroclastic material. The body decays and is removed, and what's left is just the negative, the little cavity. So they began to fill these in with plaster in order to preserve it, in order to give us the positive of what it might look like. What we're seeing here is a depiction of this person's very last moments on Earth during this eruption. Pyroclastic flows are completely deadly things. On that happy note, next session covers the types of volcanoes.